Right, today in Algebra 2, we're going to look at the second part of section 3.4, dividing polynomials. Yesterday we looked at long division. Today we're going to look at synthetic division. So the notes that you were given yesterday, you're going to pull those out, and we're going to continue with those. So look at the part where it says synthetic division. So this is the back of the first page, the bottom. It tells us that synthetic division is a method used to divide a polynomial by a linear expression in the form x minus a. You can only use synthetic division when you don't have an exponent higher than 1 on x. Okay, the leading coefficient of the divisor is 1, so you want it to be a 1x, and a is the 0 of the divisor. So example number 1, divide using synthetic division. So for when it says 0, a is the 0 of the divisor. Okay? So what that means is I take this, I'm dividing by x minus 3. X minus 3 is a 0. So if I set x minus 3 equal to 0 and I solve, I get x equals 3. So that's what I'm going to divide by. It's very important when we do synthetic division that we put a placeholder in for any variables that we're missing. So I see I have 2x cubed minus 7x squared minus 4. So I'm missing my x, okay? So you want to put 0 in for any missing x terms. Okay? This is called a placeholder. So when we do synthetic division, we only write down the coefficients, and we make sure that we are in standard form, okay? So we only write down the coefficients. So 2x cubed minus 7x squared minus 0x minus 4. I'm going to write down my coefficients. So I'm going to start with 2, and then negative 7. I'm missing an x, so I'm going to put a 0, and then negative 4. And I make a little box over here, half a little box, and I put my 0 in it, what I'm dividing by, which we solved x minus 3 to get x equals 3. And I'm just going to draw a line. My very first coefficient always comes straight down. So I have a 2. Anything down below the line gets multiplied by what's in the box. So 2 times 3 gets 6, and that becomes my next number here. I add these numbers together. Negative 7 plus 6 gets me negative 1. Below the line, I multiply with what's in my box. Negative 1 times 3, negative 3. Add 0 plus negative 3 is negative 3. Multiply negative 3 times 3, negative 9. Add negative 4 plus negative 9, negative 13. So now these are the coefficients of my new polynomial. I will always be 1 degree less than where we started. This very last number is my remainder. All right, so I started out with an x cubed, so my answer is going to be an x squared. So my answer 2x squared, because my coefficient was 2. Then I go to minus 1x, or minus x, minus 3, my remainder, so minus 13 over what I divided by, x minus 3. That is my answer. Okay? We are going to do a lot more of these examples. Notice how much nicer and quicker synthetic division goes. Okay? All right. So next page, 3x cubed minus 5x plus 10 divided by x minus 1. Again, I'm going to take x minus 1, set equal to 0 to get x equals 1. That's what's going to go in my box. And notice I'm missing a 0x squared, so I need to place 0 as a placeholder in. So write out your coefficients, starting with the x cubed, 3. The x squared is a 0. The x is a negative 5. The constant is a 10. And my little half box is a 1. My very first number always comes straight down, so 3. Multiply below the line with the box. 3 times 1 is 3. We always add these. 0 plus 3 is 3. Multiply. 3 times 1 is 3. Add negative 5 plus 3, negative 2. Multiply negative 2 times 1, negative 2. And add 2 plus negative 2, or sorry, 10 plus negative 2 is 8. write out my new answer. So my quotient is 3. It's 1 degree less than where I started. I started with x cubed, so 3x squared plus 3x minus 2 plus 8 is my remainder, divided by what we divided by, x minus 1. There's our answer. Okay. All right, so now we want to discover, so how is the value of p of a related to the remainder of p of x divided by x minus a? So to discover this, we're going to divide x cubed plus 10x squared plus 29x plus 24 divided by x plus 5. Again, we're going to do our synthetic division. So x plus 5 set equal to 0. X equals negative 5. That's the number that's going to go in my little box. I check my polynomial. X cubed, x squared, x and constant. I'm not missing anything, so I don't need any 0 placeholders. So write down my coefficients. 1, 10, 29, 24. Negative 5 goes in my little box. My 1 comes straight down. Multiply, 1 times negative 5, negative 5. Add, 10 plus negative 5 is 5. Multiply, negative 5 times 5, negative 25. Add, 29 minus 25 gets me 4. Multiply, 4 times negative 5, negative 20, and add, and I get 4. Remember, here, this is my remainder. So my remainder is 4. This is how is the value of p of a related to the remainder of p of x divided by x minus a. So my remainder is 4 when I divide. So now we want to find out p of a. What is p of a? So this is where we're going to use what's called direct substitution. Again, I'm going to look at where x is equal to negative 5. So I want p of negative 5. So direct substitution just means plug negative 5 into your polynomial for all of your x's. Right? So negative 5 cubed plus 10 times negative 5 squared plus 29 times negative 5 plus 24. Work this out. So negative 5 cubed is negative 125. Negative 5 squared is 25. 25 times 10, 250. 29 times negative 5 minus 145, and then plus 24. When I work all of this out, combine all of my like terms, I end up with 4. So I can say p of negative 5 is equal to 4. So how are they related? They are the same. So p of negative 5 equals 4 with direct substitution. When I divided, my remainder was 4. They're the same. So what that means is you can use direct substitution. You can use direct substitution or synthetic division to evaluate at a number. You will get the exact same answer. So direct substitution, you just plug the number in. Synthetic division, the remainder, right, is your answer, what you would get if you did direct substitution. Again, it's just a preference. Which one do you prefer? I think synthetic division is much faster. So let's look at this. It says show that the remainder of x cubed plus 8x squared plus 12x plus 5 divided by x plus 2 is equal to f of negative 2. So x plus 2 equals 0. X equals negative 2. That's the number that we're evaluating at. That's why it says f of negative 2. I'm going to do synthetic division first. So negative 2 goes in my little box. I have x cubed, x squared, x and a constant. I'm not missing anything, so I don't need any zeros. So write down my coefficients. 1, 8, 12, and 5. Your synthetic division, so our 1 comes straight down. Multiply, 1 times negative 2 is negative 2. Add, so I get 6. So remember, anything below the line, I multiply with the box. Get negative 12. Above the line, I add those two numbers together. So 12 and negative 12 gets me 0. 0 times negative 2 is 0. 5 plus 0 is 5. So now I'm going to do direct substitution to evaluate f of negative 2. So I'm going to plug negative 2 into my original polynomial. So negative 2 cubed plus 8 times negative 2 squared plus 12 times negative 2 plus 5. Negative 2 cubed is negative 8. Negative 2 squared is 4. 4 times 8, 32. 12 times negative 2 minus 24 plus 5. Combine all of this, work all of this out, and we get 5. So we just proved or showed that using synthetic division, my remainder is the same as using direct substitution. Okay? So of course we have some theorems about that. The first one is called the remainder theorem. The remainder theorem states that if a polynomial, p of x, is divided by x minus a, the remainder is p of a. When x minus a is a factor of p of x, we can show that p of a is equal to 0. This is called the factor theorem. The factor theorem states that the expression x minus a is a factor of a polynomial, p of x, if and only if p of a is equal to 0. So if your remainder turns out to be 0, what you divided by was a factor or a 0 or an x-intercept of that polynomial. Okay, so a nice way to solve here. So let's look at some examples using this. It says, use the remainder theorem to evaluate polynomials. Remember, anytime you see the word evaluate, you are looking for a number. Okay? So it says the population of tortoises on an island is modeled by the function p of x equals negative x cubed plus 6x squared plus 12x plus 325, where x is the number of years since 2015. Use the remainder theorem to estimate the population since 2023. Okay, so instead of plugging the number in for x and working all that out, we're just going to do synthetic division. Okay, they tell me that this is the number of years since 2015. They want 2023. So for your first thing, I need to find out what is the number that's going in my little box, right, that I'm going to divide by. Or if I were doing synthetic or direct substitution, what number would I be plugging in for x? So 2023 minus 2015 is going to tell me how many years have passed that we're looking at. Right? It's 8. So 8 is the number that's going in my little box. Okay? Look at, I have x cubed, x squared, x, and a constant. I'm not missing anything. I don't need any zeros. So we're going to go ahead and write down our coefficients. So we've got negative 1, 6, 12, and 325. Their first number comes straight down. So negative 1 comes straight down. Multiply negative 1 times 8, we get negative 8. Add 6 plus negative 8, we get negative 2. Multiply 8 times negative 2, negative 16. Add 12 plus negative 16, negative 4. Multiply 8 times negative 4, negative 32. Add 325 plus negative 32, 293. Remember that your remainder is what you would get if you plugged 8 into that equation and solved. So it says use the remainder theorem to estimate the population since 2023. So since it was like a word problem, I need to answer in 2023. There will be an estimated population of, what number did we get for a remainder? 293 tortoises. Okay. Again, synthetic division, using it this way, is just another tool that you have instead of plugging the value in for x. Okay, let's look at this again. So our next example, number 2. A technology company uses the function r of x equals negative x cubed plus 12x squared plus 6x plus 80 to model the expected annual revenue in thousands of dollars for a new product, where x is the number of years after the product is released. Use the remainder theorem to estimate the revenue in year 5. They gave me the number right there that is going to go in our little box, right? So 5 in my little box. I check to see if I'm missing anything. I have x cubed, x squared, x and constant. So I don't need any zero placeholders. So I write out my coefficients. So -1, 12, 6, and 80. First number always comes straight down. Multiply, so we get -5. Add, we get 7. Multiply, we get 35. Add, we get 41. Multiply, we get 205. Add, we get 285. This is the number we're interested in because that's our remainder. So the estimated revenue after 5 years will be, remember here they told me that this was in thousands of dollars. So, and I got 285, so we'll be $285,000. Again, this was just a different way. Instead of plugging 5 in for all of those x's and working it out, this is another way that we can work that out. Okay? So now it says 2 methods to check whether x minus a is a factor of p of x. The 2 that we've been talking about, synthetic division and direct substitution. So it says determine if the binomial is a factor of the polynomial. Okay? Remember that we had the factor theorem that told me that if I got 0 as a remainder, then what I divided by was a factor of the polynomial. So the first way that we're going to try will be synthetic on this side. So synthetic and direct substitution over here. These are the 2 ways that we're going to try. All right, so synthetic, x minus 6. So x minus 6 equals 0. X equals 6 is what's going in our box. So 6 goes in my box. I check my polynomial. I have a 4, a 3, a 2, an x, and a constant. I'm not missing anything, so I don't need any placeholders. So I write down my coefficients. 1, -8, 16, -23, and -6. Line, first one always comes straight down. Remember, anything below the line gets multiplied by what's in the box. So 1 times 6 is 6. The 2 numbers above the line get added together, so I get -2. Multiply, I get -12. Add, I get +4. Multiply, I get 24. Add, I get 1. Multiply, I get 6. Add, I get 0. My remainder is 0. Okay. So the remainder is 0. Therefore, x minus 6 is a factor of x to the 4th minus 8x cubed plus 16x squared minus 23x minus 6 by the remainder theorem, or sorry, by the factor theorem. Okay. And again, it being a factor is another way of saying that it's a 0, or it's a root, or it's a solution, or it's an x-intercept if we were going to graph that. All right, so now we're going to do it the exact same problem, only by direct substitution. So now we're going to find p of 6. So I'm going to plug 6 in for all of those x's. So we get 6 to the 4th minus 8 times 6 cubed plus 16 times 6 squared minus 23 times 6 minus 6. 6 to the 4th gives us 1,296. 6 cubed times 8, or times -8, gives us minus 1,728. 6 squared times 16 gives us plus 576. -23 times 6, minus 138, and then minus our 6 at the end. When we work all of that out, we get that P of 6 is equal to 0. So we just proved that it is a factor. Okay. All right, next page, our last page of notes. Again, we're doing the exact same thing. We're going to determine if the binomial they give to us is a factor of the polynomial. We no longer have to do two different ways. We're going to pick a way that we like or that we prefer and do it that way. I prefer synthetic division, so I will do these by synthetic division, but you are more than welcome to do them by direct substitution if that is what you prefer, okay? But I'm going to do the factor theorem because I think it's quicker. So the binomial is x plus 3, so that equal to 0, so x equals -3 goes in my box. So -3 in my box. Check to see if I'm missing anything. I have x to the 5th, I'm missing an x to the 4th, so 0x to the 4th. Then I go x cubed, x squared, x constant. So I'm only missing 1. So I would write down my coefficients. So 1, 0, -5, 9, -1, and 3. Bring my first one all the way down. 1 times -3 is -3. Add, get -3. -3 times -3 is +9. Add, we get 4. Multiply, we get -12. Add, we get -3. Multiply, we get 9. Add, we get -8. Multiply, we get 24. Add, we get, sorry, this was a +8, so that's a -24. Add, we get -21. This number is not 0. Anytime my remainder is not 0, the number is not, or sorry, the binomial is not a factor. So I can say no, x plus 3 is not a factor of x to the 5th minus 5x cubed plus 9x squared minus x plus 3. Okay, so that means that -3 is not an x-intercept of this graph. Let's look at another one. Is x minus 4 a factor of x cubed minus 10x squared plus 28x minus 16? So what number am I going to be plugging in my box? X equals +4, right? Am I missing anything? X cubed, x squared, x constant? No. So I put the 4 in the box. Coefficients: 1, -10, 28, -16. First one comes straight down. Remember, below the line, we multiply with the box. So multiply, we get 4. Above the line, we add. -10 and a +4 gets me -6. Multiply, -24. Add 4. Multiply, 16. Add 0. My remainder is 0. Right? Yay. So what does that mean? Yes, x minus 4 is a factor of x cubed minus 10x squared plus 28x minus 16. We're not graphing these yet, but you all know that's coming, right? So that means when we are going to start graphing these, +4 would be an x-intercept where this graph would cross the x-axis. Okay? All right, let's do one last example. So this one, we want to know, is x plus 5 a factor? So what number are we going to plug into our little box? X is equal to -5. So -5 goes in my box. Am I missing anything? Do I need any placeholders? X to the 4th, x cubed, x squared, x constant. No, we're not missing anything. So coefficients: 2, 9, -2, 6, -40. First one comes straight down. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. Add, What did we get? We got 5. Is 5 equal to 0? No, it is not. So by the factor theorem, we can say no, x plus 5 is not a factor of 2x to the 4th plus 9x cubed minus 2x squared plus 6x minus 40. Again, so what does that mean? When we graph this, -5 would not be an x-intercept. Okay. All right, so that is it for today's notes. That's the end of chapter 3, the first part of chapter 3, 3.1 to 3.4, synthetic division. This was the last step that you had to learn how to do before our test. So your homework, just like I promised, is in Envision, so you'll get immediate feedback on whether or not you're doing it correctly or not. So if you log into Envision, your assignment will say 3.4, day 2, synthetic division. So you're going to do those. Remember, once you complete that, take a screenshot of your score, submit that to me in Canvas, because that's where I'm going to be looking at grading while I'm gone. Tomorrow, we will look at the review. And then on Thursday, we will take the test over 3.1 to 3.4. Hope you all are doing well. I miss you.